ಹಲೋ ಆಕಾಶ್. ಆಕಾಶ್. ಹಲೋ ಆಕಾಶ್.
Yes, sir.
ಇಸ್ ವಾಯ್ಸ್ ಆಡಿಬಲ್?
ಹಾ.
ಎಲ್ಲ ಕೋಳಿ ಕೂಗ್ತಾ ಇದೆಯಲ್ಲ.
What, sir?
ಕೋಳಿ ಕೂಗ್ತಾ ಇದೆಯಲ್ಲ ಮನೆಯಲ್ಲಿ. ಎಲ್ಲಿ ನಿಮ್ಮೂರು? ಕೋಳಿನ ಮೊಬೈಲ್?
ಕೋಳಿ ಸರ್.
ಒಬ್ಬರೇ ಇದ್ದೀರಾ? ಇನ್ನು ಉಳಿದವರಿಗೆಲ್ಲ ಜಾಯ್ನ್ ಆಗ್ಲಿಕ್ಕೆ ಹೇಳಿ. ಶುರು ಮಾಡೋಣ. ವೆಂಕಟೇಶ್. ಶುರು ಮಾಡೋಣ. Good afternoon, everybody. So let us start this session. That is third module of fluid mechanics. So here, last class I told let us discuss Rayleigh's method. In Rayleigh's method, some steps are given here. List out, see this page is appearing on your screen, it seems. In the Rayleigh's method, there are 4 steps. List all variables, and then we have to see which is the dependent variable and which is independent variable. And now we have to write that equation in some form. Simply I can say x is an independent variable. Let us assume y is dependent variable. Then y can be expressed as x raised to something n, which is what we have to do. So in any let us solve one problem here. Say, assuming the viscous force, you can see the example 8.18. This is very important from examination point of view. Let us discuss this problem and let us go back to what are the steps that are followed in the Rayleigh's method. So this chapter is again the continuation of what we did in the last class, that is dimensional analysis. And in this chapter, all of you should score 20 out of 20 marks by knowing or by learning how to solve a problem. This problem, Rayleigh's method, see example 8.18. Here, assuming the viscous force F exerted by a fluid on sphere of diameter d depends on viscosity mu, mass density rho, and velocity of sphere v. Obtain an expression for the viscous force. This is we have to solve using the Rayleigh's method. See here, the problem what it says, the force exerted by a fluid on a sphere that depends on four parameters, four variables. That is, it depends on diameter of the body, it depends on viscosity of the fluid, and this depends on density of the fluid, and also it depends on velocity of the sphere. So this problem is, some sphere is moving in fluid with velocity v. Because of this movement, some force will be exerted on the sphere by fluid. That fluid force depends on diameter of the sphere, viscosity of the fluid, density of the fluid, and velocity of the sphere. Now, in this case, without any derivation and all, we should find how this force F is related to d, mu, rho, and v. First, we have to write F is equal to k something constant, and in bracket we have to express that in terms of t raised to a, mu raised to b. Like this, we have to form an equation. Then we will come to know how F is related to all these variables. ಇಲ್ಲಿ very important thing, we should know the dimensions of force, diameter, viscosity, density, and velocity. I told you in the first class, for any quantities, period quantities, you should know how to write these dimensional forms. F is equal to mlt minus 2. First, you remember the units for force. Unit for force is Newton. Newton is nothing but mass into acceleration. Mass is m. Acceleration is Lt minus 2. Like that, you should be able to write this. So when we get some time to refresh all these things in the classroom, I will tell you more about this. Diameter is measured in meters, centimeter. That is, it has only length dimension. Mu, last class I have shown you, ml minus 1, t minus 1. And rho, that is kg per meter cube. Kg is measured in m per meter cube. L raised to minus 3 meter cube ಅಂತ ಹೇಳಿದ್ರೆ length dimension. ಅದೇ ತರ velocity ಅಂತ ಹೇಳಿದ್ರೆ meter per second. L t minus 1. These are all the dimensions. ನಮಗೆ ಇದೆಲ್ಲ dimensions ಗೊತ್ತಿರಬೇಕು. Then only we can solve the problem. You need not remember all these dimensions, but you should be in a position to get these dimensions by knowing the unit of the physical quantity. Now, F depends on d, mu, rho, and v. F is a dependent variable. It is written on left side. D, mu, rho, and v are the independent variables which are on the right hand side. See here, d instead of d I have written L raised to a, ml minus 1, t minus 1 raised to v. Like that, here raise power a, b, c, t. Now left hand side we have mass quantity, right hand side also we have mass quantities, and then left hand side we have length quantity, right hand length. Left hand side t quantity or time quantities are there, and here also time quantities are there. The only thing is, by equating the power of these quantities, we have to find what is the value of A, B, C, and D, power of those quantities. From here onward, it is some tricks you have to use. See, first one, 1 is equal to B plus C. What is that 1? 1 is the power of M on the left hand side. Mass has the power is M raised to 1. That is not written here. Left hand side mass has power is equal to 1. Right hand side you check. In the second part, M L minus 1 T minus all raised to B. Here, M raised to B is the power of M. B is the power of M. So let us take the power B. And then if you go to one more term, ML minus 3 all raised to C. The M raised to C can be written here. The left hand side, the power of M is 1. And right hand side, the power of M is B plus C. That we have written. Similarly, let us equate the power of L. Power of L on the left hand side 1 and power of L on the right hand side is A plus minus 1 into B, that is minus B, plus minus 3 into C, that is minus 3C, and raised to 1 into D, that is D. Similarly, now let us equate the power of time. Left hand side power of time is minus 2, and right hand side the power of T is minus 1 raised to B, that is minus B, and the last one minus 1 raised to D, that is minus D, minus B, minus D. By equating all these, we got three equations, 1, 2, and 3. So from this equation, now we have to find the values of these. By three equations, we can get what is the value of C and D. From first equation, C can be written as 1 minus D. From the second equation, we can write D is equal to, from the third equation, we can write D is equal to 2 minus B. And we got the value of C here, D here. Let us substitute these two in the equation 2. From equation 1, we got C. From equation 3, we got D. And let us substitute value of C and D in the equation 2. By substituting that, we will can solve A is equal to 2 minus B. We got the value of A is equal to 2 minus B. Let us keep B as it is. And C value also we got here 1 minus B. And D value also we got 2 minus B. We can observe here all powers are expressed in terms of B only. So let us go back to this equation, that is F is equal to something D. Now this is here. So now we can write force F is equal to D raised to A. Instead of A, we have done 2 minus B. Mu raised to B, as it is. Rho raised to C, C is equal to 1 minus B. And B raised to 2 minus B, because D is equal to 2 minus B. The right side you can see all variables are in terms of B1 power. Okay, so finally we can write it as F is equal to D square rho raised to 1 and V square, and this minus B, mu is raised to B, D is raised to minus B, rho is raised to minus B, and V raised to minus B. All those things can be taken to denominator, and finally we can write F is equal to D square rho V square and a function of mu by D rho. We need not write that B. It clearly says that it is some constant, that is D square rho into V square, and a function of mu by D rho V. This is the equation we get, which establishes the relationship between force, diameter, density, viscosity, and velocity. This is called Rayleigh's method. Now let us go back to Rayleigh's method here. So what are the steps? Now step 1, step 2, step 3 you can write, and this Rayleigh's method expresses a functional relationship between variables in an exponential form. In this method, dependent variable is expressed in terms of independent variable. Now you can understand that statement. Step 1, we have classified what is dependent, independent variable. In our case, f is only the dependent variable. Where we have written f, which is function of d, v, go on. And then we expressed in the step 3, f is equal to some constant into d raised to something, v raised to something, mu raised to something, and also c. So finally, we got relationship between f and dependent variable and independent variable. This is how we have to solve this Rayleigh's method. This Rayleigh's method, let us take up some 2-3 problems in the classroom also, because you understood to some extent only you can understand these things online. To solve some 1 or 2 problems, then you will be familiar with and you will become expert in that. Next, in this chapter, this Buckingham pi theorem is very, very, very important, and you depend more on this dimension analysis. As I told in the first class, this, as I told in the first class, this will appear for 12 or 15 marks. Some 5 to 6 marks theory will be there, and there will be one problem. 100% there will be one problem on Buckingham pi theorem. In that 5 to 6 marks, they may ask that Rayleigh's method also. They may ask theory, or they may ask, or sometimes they ask you write the different steps that was involved in Buckingham pi theorem. So it states that the definition is here, this you have to boil. If there are n variables in a physical phenomenon and the variables contain m primary dimensions, then the variable quantities are arranged into n minus m dimensionless groups. These groups are called as pi terms. First, you have to understand what is dimensionless group. See, let us take an example of a rectangle. A rectangle has a length. Let us take it as length is L, and it has breadth B. So now L by B we can write, that is the ratio of length to width or breadth. L unit is meter, breadth unit is meter, but when we write length divided by breadth, that is L by B, meter and meter cancels, and that becomes a dimensionless number. L by B becomes dimensionless number. So in this Buckingham pi theorem, that is the most important thing. We have to find dimensionless groups. That is, in other words, if a function depends on too many variables, in the previous example, it depended on diameter, viscosity, velocity, and density. So using that, somehow we can do v divided by something, rho into mu, so that the units should get cancelled, and finally we get some dimensionless number. Sir, why to form that dimensionless number? What is its importance? To form dimensionless number is it helps in testing. Instead of doing some 5,000, 10,000 iterations to test something, for example, flowing of a boat in water, we have to test so many cases, but by using this dimensionless number, that 2,000, 3,000 iterations can be reduced to some 50 to 100 testings are enough, so that you can test your model so easily. That is the importance, main objective of Buckingham pi theorem. I don't want to explain all these things in detail, you will not get it. And also this theory part also I will not explain. I will solve one problem, and later let us come back to this theory. You please go through this in the textbook, and you please practice this some 5 to 6 problems. You have to practice to get 20 out of 20 in the third module, and also to pass fluid mechanics. Now, before going that, let us see what is the selection of repeating variables. And this is, you will understand later. Now you remember this geometry of flow. Geometry 1, flow properties 2, fluid properties 3. You remember this. I will tell you while solving the problem. What is geometry? Length, diameter, height, width are all geometrical dimensions. What is the flow dimension? Velocity, there should be movement. Velocity, acceleration, force, power, force, there should be movement. Power, there is movement. Speed, there is movement. So, these are flow related variables. Similarly, last one is the repeating variable is fluid properties. Properties density, specific weight, viscosity, surface tension. These are all properties of fluid. You remember this, if I write this one, the following variables are commonly considered as repeating variables. See, I take only one example of L, P, fifth one, 1, 2, 3, 4, 5, fifth one. L, that is a length, that is geometric property, and V, velocity, that is a flow property, and the last one is rho, that is a fluid property. So, like this, you remember this. Let us see how to use this problem. A very simple problem. Next class also I will take up this problem. I think this is enough today, and it's already, we have taken some 20 to 25 minutes. In the next class, I will take up some 2-3 problems. We'll take up some 2-3 problems. This was a very important problem. I had given last batch. I had given in of them in the internals also, and the same problem appeared in the examination also. It is appeared in 2013, 2014. It for 10 marks. Sometimes they will ask some bigger question for 12 marks or 14 marks also. Let us see how to solve this problem. Don't miss the next problem. And to some extent, you have understood what is all these dimensions, M, L, T, and all these things to some extent. If they are not understood, please go through that and be prepared for coming next class. And let us see how to apply Buckingham theorem to solve this problem. And this is all about in this session. So if there are any problems, not audible or some video problem and all, please call me. My number is there in the group. Please call me and share your responses and share your views. Okay. And thank you for joining this session. I will let you know what is the next session. Session, Shiv Ganesh, or someone who is listening, please. I want this attendance to please post the attendance. Those who attended this session, please post the WhatsApp group. Thank you.
Thank you, sir.